In my previous video, we arrived at the impedance given as root r squared plus xl minus xc all bracket squared, okay, where r represents the resistor measured in ohms, the xl represents the inductive reactance of the inductor measured in Henry. Then xc represents the capacitive reactance of the capacitor measured in farad or microfarad. Even the inductor can be measured in millihenry. That means you need to convert from millihenry to Henry. That's the standard XI unit. Alright, if you check very well, if you look closely, you will see that there is VR, that's the potential drop across the resistor. There is also VL, the potential drop across the inductor. We equally have VC, the potential drop across the capacitor. Alright? So if we take all these into consideration, we need to explain further what happens here. Alright? So the next thing we need to do, we recall that we have the following, and then that is R for the resistance measured in ohms, alright? And then we have XL, the inductive reactance, which is given as 2 pi FL and is also measured in ohms. We will need to take care of this, which is XC, the capacitive reactance of the capacitor, given as 1 all over 2 pi FC is also measured in ohms. This is ohms, symbol of ohms. Okay? Now we have understood this. There is something we need to do, and it's very simple. We need to find the reactance of these two, and that can be found using a letter X, which is given as XL minus XC. If we do this, there may be all squared according to the formula we have here. So whatever we have, by the time we substitute the value of the inductive reactance XL from here, okay, and then the value of the capacitive reactance XC, okay, by the time we substitute, we now find that this will give us a certain value which can be estimated as something, right? That is it, okay? It means that X represents the reactance of both the inductor offering some amount of inductive reactance and the capacitor offering some amount of capacitive reactance. So if we do that, we now redefine this equation X. We can now redefine equation X. But before we do that, there is another way to represent this equation S, and then we now go ahead and redefine it. So equation Z equal to all that, okay? We maintain our resistance as R squared plus, bracket open, for inductive reactance, we use omega L, okay? For capacitive reactance, we use omega C, and all brackets squared. We extend this. Of course, we should know that omega is given as 2 pi f, or 2 pi ft, so to say. But this time around, we are referring to a particular component, so there is no time attached to it. Alright? So that's what it means. That is what it means. If we now substitute these accordingly, we are not going back again, okay? But what we already have, if we now substitute accordingly, we now have Z is equal to squared R square root of R squared plus, bracket open, for this we have 2 pi FL minus, for this we have 1 all over 2 pi FC, all brackets closed and then squared. Can you see that? Very simple. I take more chalk. So this is the same as this. Because we have successfully defined that omega here simply means 2 pi f. And that is this. So if we take 2 pi f, put it here, and put it there, we arrive at this. That's what it means. It's not difficult. It's very simple and clearly explained. Now we have found that. We recall, look at this. We are going to find the reactance of the inductor and the capacitance, and that will give us x. That x is given as omega L minus omega C or squared, just like I said earlier. Okay? That is it. So if we move further and substitute accordingly, what we have is what we already know. Okay? So what do we have? It's simply the same thing. We have XL and XC, right? How do we now find XL and XC? It's simply by substituting accordingly. And when we do that, we have 2 pi FL. For the inductor, we have this to calculate the inductive reactance, XL. Understand that? So for the capacitor, we have minus 1 all over 2 pi FC to calculate the capacitive reactance of the capacitor. And by the time we do this and evaluate accordingly, taking note of squared, all right, and we are done. That gives us the value of X, the reactance. The reactance is referred as X. This simply means the reactance. Okay? And is measured in ohms. The reactance is measured in ohms because we are talking about some amount of opposition offered into the flow of current in an AC circuit. Of course, it's an electric circuit, though it's now being powered by some kind of AC source. So it's okay. And finally, what do? We redefine this. We now redefine this, and it gives Z is equal to square root or open. We retain our R squared plus, in place of this, we have omega. We don't need to restate it again because we have found the reactance. We have found the reactance, okay? So we can now just say X squared. That is it. Simply that. So when we find that, we are happy. That is what we should do. Okay? The reactance is given at that because it's going to be some sort of clearing what we have, and we arrive at that. By the time we do this, we can now solve to get the answer or the solution of the impedance Z using very shortened the formula. Very simple. Cross-check if there is any of the steps that is not clear. Put it in the comment section. Alright? While doing that, while you are stating your concern in the comment section, remember to give me some thumbs up. Come on, my friends. Come on, my friends. My viewers. Alright? Put on the bell button for constant notification. Don't you like this? Put it on. And then share with your friends, networks, and students. I will continue to dish out learning in this form, in this raw form. Don't mind what you are seeing, just mind what you are learning. Thank you, and see you in my next class. I will hang it over there, or I will link it over there. And at the same time, you see my students hanging, yes, because I don't want you to distract me from teaching you. Okay? See you. I move. Sign out.